Okay, we're going to talk about a particle slowing down and speeding up, and we're going to use a tool called Sine Analysis. Now, remember what it meant to speed up. Okay, speeding up is when a particle is moving in the same direction as it's being pulled. We can measure the movement of a particle by computing the velocity. And that will give you the direction. Positive velocity means it moves to the right or up, simply moves in the positive direction. Negative velocity means it's moving to the left or down, simply moving in the negative direction. So velocity can measure the direction of travel. Acceleration, if you guys recall, measures the push or the pull. So force equals mass times acceleration. So if it has positive acceleration, the particle is being pulled or pushed in the positive direction. And if it has negative acceleration, the particle is being pulled or pushed in the negative direction. So it's important for us to determine the signs of both velocity and acceleration. And when they have the same sign, that particle is speeding up. And that's the idea. Similarly, slowing down, a particle is moving in the opposite direction as it's being pulled or pushed, the force. So again, velocity gives you the direction the particle is moving. Positive velocity, particle is moving in the positive direction to the right or up, depending on the nature of the problem. The negative acceleration means it's being pushed or pulled, force equals ma, in the opposite direction. So it's going to slow the particle down. When your velocity is negative, particle is moving in the negative direction, down or to the left. And a positive acceleration means it's being pushed or pulled in the positive direction. And so when you compute both velocity and acceleration, if the signs are opposite, then the particle is slowing down. So this is what we mean here by when particles slow up or particles are slowing down or speeding up. So these are kind of the concepts behind that. And we talked about this already, and I'm going to go through here now an example of using sine analysis and actually just looking at the curve, both velocity and acceleration curve. We can deduce the same kinds of things, but I think sine analysis is a good place to start with this. So here's the position function, and s of t is t cubed minus 12t squared plus 36t. The interval they're giving us is to only consider time between 0 and 8 seconds. So here's the position function. We need to start with that position function, because to get the velocity function now, right? The velocity function is the derivative of the position function. So we have to differentiate the position function of t cubed minus 12t squared plus 36t. T cubed minus 12t squared plus 36t. Okay, now using properties of derivatives, you get t cubed minus 12 dt t squared plus 36 d dt of t. Power rule, 3t squared, 2t, 1, 3t squared minus 12 times 2t plus 36 times 1. So we get 32, or 3t squared minus 24t plus 36. So our velocity function, ladies and gentlemen, is what you see here. So we want to find where this velocity function is positive, negative, and zero, because we're going to talk about the speeding up and slowing down criteria that we have here. So we need to find, perform sine analysis on the velocity function, but also on the acceleration function. So here's what I'm going to do now. I'm going to take that velocity function, and now I'm going to differentiate the velocity function. So acceleration, by definition, is the derivative of the velocity. So let's differentiate velocity. 3t squared minus 24t plus 36. Use properties. And now, power rule, 2t, 1, 0. So we get 3 times 2t minus 24 times 1 plus 0. We'll get 6t minus 24. So we have the acceleration function, 6t minus 24. Okay. All right. So remember, we're going to do sine analysis on both of these functions here. And we're going to try to see if we can figure out, when the particle's slowing up, when the particle's slowing down. All right. Now, I'm just going to show you a picture here. We'll get back to this of the velocity function. This is what we just found. This is going to have a lot of meaning for us. Acceleration function, 6t minus 24. It's going to have a lot of meaning for us as well. But we're going to try to do sine analysis, see if we can figure out particle moving, slowing down and speeding up. So remember, the sine analysis procedure starts by setting Vt equal to 0, meaning where do you have 0 velocity? So factor your 3 out. And we can factor the t squared minus 8t plus 12. That'll be t minus 6 and t minus 2. And now we could divide both sides by 3. You'll end up with t squared, t minus 2 is 0 here. So t minus 6 is 0, or t minus 2 is 0. This means t is 6. And this means t is 2. So I have 6 seconds there, 2 seconds. This is where my velocity is equal to 0. Now, if I go back and take a look at this curve here, this velocity function, take a closer look. What that is saying, this is my time axis. This is t versus v here. Okay, it's a parabola. And of course, at 4 seconds, this is where my velocity, this is v of 4 equals 0 here. So let me show you guys that the velocity at 4 seconds here. Oops, I apologize. That's not. We'll get back to this. The velocity at that 2 seconds is 0. And velocity at the 6 seconds is 0. This is what we're looking at. Okay, and that's what we just found in sine analysis, just to kind of remark there. We'll get back to this remark. So we want to find where this is positive, where this is negative. So we know t of 6 is The t values here is what we know. Let me move this out of the way. Okay, so we're going to do some sine analysis here now. I guess we'll do it right here. Now I'm going to say here t is from 0 to 8. So this is where 0 starts, and this is 8. This is for the velocity. We know at 2 seconds and at 6 seconds, the velocity is 0. So this is going to partition my t axis into 1, 2, 3 regions for sine analysis. I'm going to pick a number, a value in each region as a test point for this velocity. Now, we could use either this 3t minus 6 times t minus 2 or the one below this. It won't matter. We're trying to test where the velocity is positive, where the velocity is negative, using test points for every region here. So when we test the value 1 here, put in 1, we're going to test region 1 for its sign. If it's positive or if it's negative, we get 3, 1 minus 6, 1 minus 2, 3 times negative 5 times negative 1, which gives me positive 15. So what I know here is that region 1 now is positive here. I have 3 regions, so region 1 is positive. So the test point gives me a positive region. Change your test point now. Testing region 2 by the test point of 4, a number clearly in region 2. 4 minus 6 is negative 2. 4 minus 2 is 2. And that's negative. So we get 3 times negative 2 is negative 6 times 2. This is negative 12, ladies and gentlemen. So region 2 is negative. So this is how we test region 2. Let's test region 3 now by using the test point of 7. And when we do, plug in a 7 for t. 7 minus 6 is 1, 7 minus 2 is 5, and then this will give you a positive 15. So region 3 is positive. Okay. All right, now this is where my velocity, ladies and gentlemen, is positive. So notice this. I'm going to shade this region blue here. Okay, positive. Oops. And negative here for region 2. Now I'm going to describe the values here of t, where the region's going to be positive, where the region's going to be negative. Now, here's what we can say. V of t is greater than 0. If we look at this in terms of interval notation, this is 0 to 2. Okay, now if you say, what was v of 0? If I go back and try to find v of 0, the velocity here, well, I can plug the value in, but v of 0 is up here. That looks like it's 32 for 36. So v of 0 is a positive 36. Similarly, this is when t is 8. V of 8 on this curve is positive 36. This is the velocity function again. Okay, so the point I'm making is when I give my solution here, I'm going to include 0 because it's positive velocity. And that's going to be the union now of 6 up to 8 with a bracket because we have to include the 8. Because v of 8 is positive, so those are positive values. So this is where it's positive velocity. Negative velocity is actually between 2 and 6. Notice we don't include the 2 or the 6 because v of 2 is the same as v of 6, and that equals 0. So these are strict inequalities. This is the meaning of positive and negative. So this is interval notation. This is just where the velocity is increasing. I should say, let me take that back. This is where the velocity is positive, velocity is negative. By the way, the particle's moving to the right here or up because it has a positive velocity. The particle is moving to the left here or down because it has a negative velocity. That's going to be useful information. And now, this is exactly how I summarized it here for us, so you guys can see. So it's the same kind of summary, so I wanted to give you guys that summary there. Now, acceleration sign analysis. You say, what about for acceleration? Well, sign analysis here again starts where a of t is 0, which means 6t minus 24 is 0. Or 6t is 24. When t is 4, my acceleration is 0. So I'm going to go through the same process, start at 0, end at 8. We know at t is 4, the acceleration now is 0. And that partitions your real number line there, or this line segment, into 2 regions. We're going to test the signs for both regions. So we're going to use -3 as a test point and maybe +5 as a test point here. And you say, what are we testing? We're testing here acceleration. We're testing 6t minus 24. That's my acceleration. Okay, because we got the time value here being 4 here. All right. We're going to check the signs, where it's positive, where it's negative. So the test point here now, if we use 3, we get 6 times 3 minus 24. We get 18 minus 24, and that is -6. So my acceleration is negative in region 1. If I test 5 now, we'll put it over here. 6 times 5 minus 24 is 30 minus 24, and that answer is +6. So region 2 is positive. Okay, now let's look at this acceleration curve just to note when we start to put our conclusion here, right? This point down here, this is where a of 0, and that looks like it's going to be -24. And then similarly, this point up here, that's a of 8, and that's +24. This is going to be useful information here. And then notice again, right in this middle here, at 4, what that'll mean at 4 is simply that a of 4 equals 0. Acceleration at 4 seconds is 0. And that's just looking at your acceleration curve, which happens to be a line. And it's a line segment because it's over the time interval of 2 seconds there. I'm sorry, of 0 to 8. So here's t, a-axis. It's a of t. So if we do the same kind of analysis here, let's notice that the region here where it's positive is everything to the right of 4 up to 8, where it's negative is right here. So I'm going to draw my conclusion here looking at my sign analysis information. I'm going to erase this here. And so we're going to describe acceleration. Acceleration is negative for The time interval of 0, including 0, up to 4, do not include 4, because a of 4 is 0. That's when you have negative acceleration. Positive acceleration happens for values to the right of 4 up to 8 and including 8. Because we know a of 8 is negative. We know a of 0 is positive. This is what my sine analysis picture tells me. So if we go back up here, let's verify that. Yes, at the endpoints, at 0, it's negative, and at 8, it's positive acceleration. So this is verified on the curve. And so, ladies and gentlemen, that conclusion is described right here as well. Okay, and I want to describe this to you as well here. Positive from 4 to 8, yes. Negative from 0 to 4. The particle here is being pushed or pulled, right? This is to the right or up in the positive direction. That's the pull. Acceleration. Negative acceleration, you're going to either be pulled to the left or down. So this is the pull. This is the force, because this is how acceleration works. F equals ma. Force is mass times acceleration. So we have that summary. And to go back to what we're talking about originally with this, the whole essence of this exercise is to show people about this idea of pushing and pulling, right? Speeding up, slowing down. Again, you are speeding up when both velocity and acceleration have the same sign. Both are positive or both are negative. You're slowing down when both velocity and acceleration have opposite signs. One's positive, the other's negative. So a good way to look at this picture is, if you do use sine analysis, if you're using sine analysis like this approach is, and I'll show you another method. Using sine analysis now, you're going to put here both the velocity and the acceleration on top of each other. Sort of. Align them. So here's what's going on. If we can move them on top of each other. This was the picture for velocity. So you're going to locate for both the zeros, and you're going to partition right in here. You're going to partition along the zeros. So here and here. This is for the velocity. Now for the acceleration, if you put both of these on top of each other, there's only one zero for acceleration. You're going to partition here. So partition along where both velocity and acceleration are 0. You're going to partition both of your sine analysis information. So that's what I did up here. I got acceleration by sine analysis. We got velocity by sine analysis. And you're partitioning along the zeros here and kind of show you how that might work. You know, you might have to, let's get the acceleration. But since I did this different sizes, you know, I don't have such an easy way to resize. That's what I'm saying here. There we go. Maybe something like this. You know, you kind of line them up along the zeros. And let's undo this to get rid of these annoying test point that doesn't help us at this point. And we're going to get rid of this. Get rid of your annoying test points. So you're just lining this up. And you did it along this zero. This zero, you can do it along this zero. But remember, this location was 4. Okay? So this is what I'm describing here. This is your velocity and acceleration here. And this now partitions. You have now 1, 2, 3, 4 regions. So if I said to you, which regions have the same, are both positive, have the same sign, both positive? Well, region 4, they're both positive. Velocity and acceleration are positive. They have the same sign. Region 2, both velocity and acceleration have the same sign. So we're going to care about that. And then maybe in green, opposite signs for velocity and acceleration are region 1, region 3. Velocity and acceleration are opposite. So if you line it up this way, which I did here, nicely and cleanly, we'll do this again. Go through region 1 and you notice in region 1, the signs are opposite. So I'm just going to say, see, this is positive, this is negative. They're opposite signs. This is what we're talking about. Region 3, velocity and acceleration have opposite signs. So where it has opposite signs, this is where you are slowing down, and that is from 0 to 2. And then we're going to include from 4 to 6. So here is what we're saying down here. You're slowing down in region 1, region 3. And this is how we describe region 1, from 0 to 2, and then from 4 to 6. And let me be careful here. Okay. Do we include? Yes, we include 0 because they're opposite at 0. We know that. Okay. And we don't include 2 because at 2, velocity is 0. 0 and negative, they're not opposite signs. So this is why it's an open interval at 2. And then the same thing for 4. Velocity is negative at 4. Acceleration is 0 at 4. Those are not opposite signs. Remember, we mean opposite by positive and negative. 0 is neutral. So we don't include 4. Same thing at 6. Velocity at 6 is 0. Acceleration at 6 is positive. They're not opposite. So those are open intervals there. And this is where the particle is slowing down. Now, compare that to region 2, where you have negative velocity, negative acceleration. They're the same sign. And so this is where your particle is speeding up because it's being pulled in the negative direction while it's moving in the negative direction. So it's speeding up here, ladies and gentlemen. Same thing for region 4. Velocity is positive. It's moving in the positive direction, and acceleration is positive. It's being pulled in the positive direction. So you're looking at this information here. And so the interval for region 2 will be from 2 to 4. The interval from region 4 is from 6 to 8. You say, why did we include the 8? Because at 8, both velocity and acceleration have the same sign. So this is how we can find where particles are speeding up and slowing down by using the technique known as Sine Analysis. And that was the whole idea, to show you this by Sine Analysis. Now, you might say, Mr. Judge, did we have to do this by Sine Analysis? And I'll say no. So notice the homework that they gave you on this question was prior to Sine Analysis. What they want you to do here is the following. Remember what we started to mark above. I want you guys to know something here. Let me see if I can stick with the same colors. Oh, no, we can't. We're going to have to do something like this, okay? What I want to say to you guys is this. The parabola in blue, this is my velocity curve. In green, I have the acceleration curve. Now, this is a time axis. And so every point on the curve is a point for either acceleration versus time or velocity versus time. Now, I want you guys to notice something here again. This is the zeros for your velocity. This is the zero for the acceleration. Okay? What's important to know is every point above, we will use what color? I guess gray. Every point, ladies and gentlemen, above the time axis, every point above the time for acceleration here, this acceleration is positive. So every point above there is positive for your second variable, and that's not acceleration. I take that back. Every point above, this was the velocity curve. It's in blue. Positive velocity. Positive velocity, ladies and gentlemen. It's above this axis. Once it gets below the axis, then that's negative velocity. Negative velocity. So for any point below, this is where your velocity is negative, and maybe I'll shade that red. Okay, so you have negative velocity when it's below, positive velocity when it's above, and the same thing is happening for acceleration. Here, acceleration is above the t-axis, so your acceleration is positive. Any point below, acceleration is negative here. So I drew the same sort of boundaries here, as you guys can see, at 2, 4, and 6. And you're going to use the criteria of speeding up and slowing down in region 1 and region 2, region 3, region 4, through the same zeros for both velocity and acceleration, because they have the functions on the same Cartesian coordinate system. Just check these points. Region 1 is simply describing the following. Velocity is positive and acceleration is negative, ladies and gentlemen. So in region 1, velocity is positive, acceleration is negative in region 1. So you're slowing down in region 1 here. This is region 1. Slowing down. Maybe I should move that up here. So you can look at the curves and you can deduce what's happening. In region 2. Region 2, both of the curves are below the t-axis. So velocity is negative. Acceleration is negative. They have the same sign. Speeding up. So let's just say slowing down. Let's put D. Speeding up. We'll put U. And what I'm saying is region 2 now partitioned along the zeros for both velocity and acceleration. Partitioned along the zeros. Both curves are below the t-axis. And then region 3. In region 3, acceleration is above, so that means acceleration is positive. But velocity in blue is negative. So they have opposite signs. So this is slowing down. I'll put slow down, speed up. Because the curves, ladies and gentlemen, in one case, acceleration is above the t-axis, velocity is below. Now look at region 4. Both curves are above the t-axis. So in region 4, velocity is positive and acceleration is positive. So they have the same sign. So this is a speeding up situation. So we're looking at this axis here from 0 to 8, and it's the same kind of thing. Okay. So you can conclude, looking at that axis again, speeding up is happening here. If I kind of, out of colors, speeding up in blue, speeding up in blue, speeding up from 2 to 4, union 6 to 8, just by looking at the curves. Slowing down, I guess we'll do this color. Here, here, slow down, slow down. What are we describing? From 0 to 2, union 4 to 6. We're looking at this picture here. So in short, sine analysis verifies what we know in terms of all the signs. This is what we did. We did sine analysis. However, a very quick way to answer this question is simply graph the velocity and acceleration on the same Cartesian coordinates through the zeros, the intercepts on the t-axis, through the zeros, partition, and see how the curves behave. If they're both above the t-axis at the same time or both below the t-axis, that particle is speeding up. If it's opposite, the particle is slowing down. And that's the conclusion there. That was using the concepts and ideas that we talked about originally here by slowing up and speeding down, ladies and gentlemen. So I hope you guys enjoy the video. I'll forward this to you guys here, but this is a great example, and people have been coming to my office for this question, and I thought I'd just formally address it in a very detailed way. Enjoy.